Hey guys, welcome to Some Dev Dude and the first video of the channel. The goal of my channel is to break down some software engineering practices and cybersecurity topics, and I want to explain not only the concept but the foundations of these topics as well. And today we'll be looking through an introduction to SQL Injection. SQL Injection is an easy to exploit vulnerability that has been around for about 20 years from what I can see after doing a little bit of research. And I want to start here because I have a plan of going through some CDFs, some labs, and I'm going to start with the Portswigger Academy. And before I do this, I want to make sure we have a good base of understanding about what each exploit is. So I'm going to start here with SQL Injection and kind of explain not only SQL Injection, but SQL Databases and SQL Queries as well. Now, this won't be a massively in-depth video, and I will leave links in the description where you can learn some more. It's just kind of giving you a basic understanding of about what SQL is and what it is used for. So what is SQL Injection? SQL Injection is an exploit where an attacker inputs a malicious value into a request, whether that being in a form, URL, or payload of a request, which then subverts the application logic, in layman's terms, makes the application do something that was not planned by the developers. It falls under the category of injection, which is the #1 risk, as described by the Open Web Application Security Project, or OWASP for short, top 10. So these guys are a not-for-profit organization that will look to improve the security of the web, and they have a top 10 list of the most dangerous vulnerabilities. So let's break it down. What is a database? So a database is a collection of data stored in an organized way. There are multiple types I should say, but two main types. We have SQL and NoSQL. A little bit confusing, I'll kind of give a brief explanation. So a SQL database I should say, stores information in a bunch of tables with a bunch of columns and a bunch of rows, which I'll break down later. NoSQL organizes data by a collection of documents. Again, not going to go into much further, but that's the basic difference between these two. And as I said, we're going to focus on SQL databases. So when I say the term SQL, I'm actually pronouncing an acronym, and that acronym is SQL, and it stands for Structured Query Languages. Now, there's a lot of bike shedding or friendly banter about the correct pronunciation. The two main ones are SQL or SQL. If there is another one, I haven't heard of it, and I'm pretty sure it'll just be weird. So SQL is the method of creating, reading, updating, or deleting data. And a SQL database is organized into tables, and each table has a definition of a certain amount of columns, and then each table has a collection of rows, which can be no rows or can be an unlimited amount depending on performance of the database. So here we have a database. Now, going through the structure, we have our database, which has a collection of tables, or in this case, just one table, users. And then this table has a series of columns. In this case, we have ID, which is a number, username and password, which are strings, and then phone number, which is a number. So the reason why the difference between numbers and strings is important is because they are the column data types. A database won't let you update or create rows that has a data type that doesn't match the column. So if I try to add a new user, I'm going to give it ID of 3 because it's the next one in the logical sequence. Tim, Bob, and for phone number, I put in A or ASDF. The database will throw an exception here because it's not matching, or this is not a number. So if I click save, error, and there's a nice little SQL error. Okay, done. So this is a basic database. Cancel that, and we'll kind of go into what SQL Injection is now. So as mentioned earlier, SQL is an acronym for Structured Query Language, which is a domain-specific language designed to interact with databases. And what I mean by domain-specific is its sole purpose is to interact with databases to help create data, read data, update data, and delete data. And there is a bunch of functionality which would require an entire series to go through, and I'm going to admit I'm not the biggest master of SQL. And these common commands or queries are insert for adding data to a database table or inserting rows, selecting, so pulling data out of a database table, update, so updating an existing row in a database table, and deleting, and you would have guessed it, deleting a row from a database table. For today, we're just going to focus on select, as I think it's a real simple place to get started. So here we use a select example of how a SQL injection attack works. The attacker enters a malicious piece of input, exploiting their knowledge of how SQL works. And we'll use that to, again, subvert the application logic and then make it do something that wasn't intended. So here we have a quick example. So I'm just going to read out the entire statement or the entire query and then break it down. So we have select all from users where username equals foo and password equals bar. So let's start from the beginning. Select. It's defining what type of query is going to happen. And with select statement, what follows the select statement between select and from defines what data you're getting. In this case, we're just using star, and star means all. It's the syntax for grab every piece of data from that row or from the rows that are returned and give it to me. After that, we have the term from, and from is used to define where the information is coming from, what tables are getting from, and you can do some really cool stuff with SQL. I'm not going to go into it, but from means where you're getting, what tables you're getting the information from. Then we have where, and after where, we have a series of conditions. The where statement is used to define what information we're going to return. So in this case, we're going to get every row from the user table that has a username of foo and the password of bar. And if there was a username, another row, the username of Jane, that would not be returned. So it'd only get the rows that have the matching query or matching conditions. But what if a attacker inputs some SQL of their own? In this case, they're putting the term admin, double quote, and dash dash. Breaking this down, admin's just the input. So instead of putting foo, like we have in the first query, we're putting in admin. And then the double quote. So in the expected example, you can see that the input value of a string is wrapped in double quotes. If a database or application has a SQL vulnerability, we could enter in our own double quotes and then close that value earlier. And then dash dash is signifying it as a comment. Now, a comment in programming is a piece of code that isn't executed by the application. It's used to kind of convey information to one another or define to-dos. So anything after that dash dash, it will be defined as a comment and won't be picked up by the database. This changes our query. So below in the example, we've got what is in white is what we're expecting. What is in red is what the attack is putting in. And what is in blue is ignored because it's become a comment. So instead of trying to match a username and a password, we're now just trying to find all the users with the username of admin. And then we're ignoring the rest. So using this, an attacker will be able to just get the admin details and then might be able to inspect the password or gain more information to use later. Okay, let's jump into a more concrete example of how a SQL injection vulnerability may work. On my right hand side, I've got a small server that will print out the SQL statement or the SQL query that we're running and then whether it logs in or not. And then over on my left hand side, we've got a small simple web form. Let's just try and, I know we've got one user that we can use, dev dude. And over on the right, you can see the select statement and we're logged in as dev. But let's try logging in as admin with the password of dude. No dice, password for admin is not dude. But here we can use our SQL injection vulnerability. Now for this particular version of SQL, the comment operator is, or the comment sign is a hashtag or pound sign. So I'm going to press single quote, and then we're going to press pound sign. Let's see what happens. So you can see we are logged in. And the reason why is this comment operator As in the previous example was dash dash, in this language or this particular SQL framework, it's a pound sign, makes the rest of this statement ignored. So all it's doing is searching for the user where the username is admin, and then that's working. So yeah, that's a very basic example of SQL injection. So let's talk about defending against SQL injection vulnerabilities. The first and most common way is to use parameterized queries. And what this means is that the query is passed to the database without the user input values, and then the database will pre-process that and understand what the query should be doing before the user input is added, and then it cannot escape or cannot change the query at all. The second method is to sanitize your inputs. So this means you want to look at a user's input and clean it up, filter it out, and check for anything that could be damaging or allow you to use an SQL injection vulnerability. We also have escaping malicious syntax. So changing potentially dangerous characters in a string, or for example, the dashes in the example, and making sure that they cannot damage the database or interact with the database in a way that's not expected. We want to remove unnecessary functionality from your database server, and what this means is if your database is only designed to have a process give it data, don't give it the ability for it to read data or delete data or update anything. We want to encrypt sensitive data. The biggest example of this is passwords. So when we encrypt something, we might take the password of password and encrypt it, and it becomes something that is not human readable easily. And while this doesn't defend against SQL or SQL injection attack, it makes it harder for the attacker to use that data because they can't read it. So they couldn't take the password and try and log into the user's account. And finally, implement a least privileged model on your database. And what this means is don't give every user or every process trying to access your database the keys to the kingdom. Lock it down, give them only what they need to do, nothing more. Thank you for sticking with me for this video. I hope you learned something. And if you have any feedback on the video, please leave a comment below. If you feel like I haven't explained something more or I've missed something out, or more importantly, if you know what SQL injection is and I'm incorrect, let me know so I can update the video and make sure I'm putting out some good quality information. Thank you for joining, and I'll see you in the next video.